So the second titration curve that you need to try is the opposite. It's a weak base with a strong acid. So we need to get the initial pH. So that's why I wrote this equation there, because I haven't added any acid. It's just being put in water. So what you need to do is we'll have values here, and that's the only value we have. So we need to just ice. And when you ice, you get to neglect the x, and you have Kb equals x squared. This one is special, though, because we have to remember that we have the OH, so we have to do the POH first, and then subtract from there. So the initial pH is 11.13. From there, we have to go halfway. So at the halfway point, pH equals pKa. We have the Kb, so you need to find the Ka. Okay, once you do that, it's pretty easy. All you do is take the negative log of that and you find the pH is 9.25. Then, at the equivalence point, I took my 0.1 molar and 0.05 milliliters, and I found that I had 0.005 moles of ammonia initially. Moles of ammonia, and then at the equivalence point, that many moles equals the acid that I add. From there, I do the Becca, because I have two things on one side, and I find 0 and 0. At equivalence point, the A values will always be 0. The after values are always 0, and it adds over here. Now remember, Becca's moles, so we need to go to liters, and I need to figure out how many liters of H plus is required to get 0.005 moles. So I take my molarity, 0.1 molar, times X liters is going to equal 0.005. And you find that you need 0.05 liters. So the total volume would be 50 milliliters plus 50 milliliters, which is 100 milliliters, or 0.100 liters. So when I ice, I remember to divide, and I get x squared over 0.05 equals the Ka, and the pH at the equivalence point is 5.28. Okay, then we have to do after the equivalence point. So I just picked a point. I knew that I'd use 50 milliliters there, so I used 60 milliliters here, which is 0.006 moles, and you subtract away all the ammonia, and you divide by the total volume, and that is the H plus concentration, and then you take the negative log of that to find the pH. Then you have to graph these points. So this is what the curve you should expect for a weak base. It starts up high at the value that we calculated. At halfway, it goes down gradually here, and then whoop, jumps really quick. And notice that here would be a pH of 7. Our equivalence point pH is lower than that, and that is because the NH4, which is the conjugate acid, is present. In strong and strong, we have no real conjugate acids or bases, so our pH is just 7. Okay, and then afterwards it slopes down. Okay, thanks.